traditional flat workflow of planar SRF and then rebuilding the surface, you can think of the SubD method of using that workflow as quad remesh. And that'll work on planar meshes too. It's very, very cool. So I'm going to take this head part here and I'm going to use bend. And I'll just bend this up so we get a little bit like that. And let's taper it. So I'll use taper like this. And I'm going to use the infinite option so that the sides stay straight like that. And I'm going to offset this sub-D same as I did the last time. I'm going to remove the creases, same as I did the last time. I'm going to show you a face loop selection. This is a fun trick. If you have Control-Shift-Click one face, Control-Shift-Click another face, and then you Control-Shift-Double-Click on a face in between those two, you get that whole loop. So you can sort of bookend your selection, get all those, and then delete. And now I've got this open end here. Now you remember the lesson I taught you about bridge. The edge counts have to be the same.
Muted.
So if I double click and get that edge loop, I see 18 edges. If I double click and get this edge loop, I see 6, not the same. But that's okay. I'm going to show you a really fun way. Well, there's really two ways. I'll tell you one and I'll show you the easier one. So one is delete some edges. You could select those edges, Control-Shift-Click them, and delete them, and you'd reduce the edge count of this loop. But you can also use bridge between just 2 and 2, like this. So if I use bridge like this, then use bridge where I can on the other side, just enter to run the same command again. You see I've got these openings here. Now I don't want to have to do the same thing on both sides. So I'm going to tab into box mode here, Control-Shift-Double-Click, make sure that is flat. I don't have a scale handle in X, so I know it's flat. And I'm going to use reflect. Reflect lets me pick a symmetry axis for the sub-D. I'm going to hold down Shift here and then click on one side, the side that matters, like that. And so now I can come in here, Control-Shift-Double-Click that loop, and it's got 10 edges, and I can use this command, fill. So fill has an automatic option. I'll just say, make it happen. And Rhino figures it out for you. So it closes up that hole. If you've ever had to close up some crazy number of sided hole on a Nurbs object, you know that that requires network surface and retrimming trimmed edges, and there's lots to it. And it's all possible, and Rhino can do it. But for beginners, it's tricky. Fill, totally a beginner way. So I think this set of features is, I think, going to really open up form finding to users that don't know Nurbs modeling. And I look forward to seeing examples of that. Now I can remove the symmetry from this object by selecting it and right-clicking the reflect icon, like that. I'll Control-Shift, Windows Select, and get the proportions a little bit better on this, like this. Hold down Shift, Scale in 2D. And there we go. We're using the same handle on two objects, like that. Maybe I take this guy out of there just by selecting and deleting. All right, so I want to answer any questions that you have, and I can, maybe demonstrate something as well. So let's see. I think I lost the webcam, but if I'm not rotating around too much, maybe I can. I'll turn it back on, just so you can see me while I answer your questions. So, any questions?
Thank you so much, Brian.
Yeah, Brian, can you make the double head fork with symmetry? I love that one. I love.
Okay. So yeah, so reflect lets you pick a reflection axis. So you could say, okay, this is going to be my reflect axis. This is the side I care about. And it tries to do that. Let's see if I can get it to figure out the end a little bit better if I do it maybe like this. There we go. So there's your double fork. If you have more mouths to feed, you can do it in one. It's pretty flexible. There's something to note about reflect. The reflection boundary there, if you cross it, it's going to try and merge stuff together. So there's actually in reflect a setting that controls that distance when it's going to try and join stuff together into one. So if you really want to control it, do it that way. How I'm liking to use this is adding and removing it on the fly, like that. So any other questions besides for ruining the fork design?
No. Some people want to know if you can take that Subdi and make a beautiful mesh, like for an STL file.
Oh, absolutely. The Subdi conversion to Nurbs is one thing, and that's actually mathematically the hardest, most impressive thing that we've done. And my hat's off to the developers that did that. But in terms of meshes are easy peasy. And I'm going to show you first the coarsest mesh of all, which is going to be what you see in box mode. So if you want to go to an animation program, for instance, that has Subdi mesh modifiers like Maya, Max, Blender, whatever, send them this, because it'll be the same shape once you subdivide it 3 or 4 times. It'll look just like this. And to get that, it's extract control polygon. So extract control polygon is going to give you a mesh that is that. All right. And this isn't what you're going to want to 3D print. But if you want to go to an animation program or a mesh modeler that has Sub-D, subdivision modifiers in it, this is what you want to send them. Now, you can also use the export command. And the export command is going to give you, let's see, your OBJ, right? Let me say test, whatever. And we get our options here, Sub-D meshing. So Sub-D meshing lets you choose how many subdivision levels you want it to have. So if you left it on the default, it's going to be indistinguishable. It's going to look just as smooth as you see it on the screen. If you wanted to use that control net that I showed you with extract control polygon, you would use this option. So these are in the OBJ export options, or they should be there in the STL export as well. You could also, just like you can on Nurbs objects, you could use the mesh command, bring up detailed controls, and you'll see Sub-D meshing parameters. So let me see if I drag it down here and click preview, that would be the number of polygons versus that, versus that. So probably this last or second to last would be fine, depending on how large you're going to print it. But you can see all the little tiny quads that you'd get, all the mesh faces that you'd get. So that's with the mesh command. I often like to do that if I'm going to print something, rather than exporting, opening it up again and checking it out. I just use the mesh command, make the mesh, check it out in Rhino and say, okay, is this mesh good? What is it? It's a valid mesh. It's closed. It's got 6,300 faces. Everything looks cool. So I know it would print. Any other questions?
We have several questions on the chat.
Okay.
So
do you want me to try and find them, or do you want to just tell me what they are?
Can you make a flat UV map from a SubD?
Yeah. So SubDs work the same as Nurbs polysurfaces or meshes. You can make custom unwrap with them and select the edge loops that are allowed to rip apart. So if I select, these pieces here, this would be one island in the UV editor. Yeah, so it works like you would expect with Nurbs objects where you select edges as the seams. They are just edge loops in the SubD.
Perfect. And Brian, can you show just a little bit when you push and pull a SubD, that beautiful interface that shows the sphere of what area it is controlling?
Oh, are you talking about soft transform?
Yes, yes.
Yeah, soft transform is very powerful, but it does require you to be aware that it's on.
Okay.
So I'll show you what I mean here. So if I have these two faces selected right now and I scale in 2D, you can see where the scale stops, right? I start to end up making, actually this would be pretty good for ice cream, I think, wouldn't it? I start to just make this deformation like this, but it's not going any further. So what Andres is talking about is this command, soft transform. Now, if you have sub-objects selected, and that's the important part, if you have sub-objects selected and you click this icon, soft transform, you'll get this red sphere. And this red sphere is indicating how far within the SubD any edit to the current selection will impact. So I set it about there, and now when I do the scale 2D, you can see that it's going all the way back to where the end of the sphere was. Soft transform I find incredibly useful in the UV editor because it will work on meshes as well. But here's the thing. It is on right now, and I don't know it's on. So if I start moving something, I'm actually using the previous radius for soft transform. So if you right-click this icon, you'll toggle it off. And you can see in the command line, it's enable equals no. So it's a little bit dangerous in that if you forget that it's on, then you might get confused. But otherwise, it's very, very useful. Any other questions?
What's the relationship between Sub-D and Grasshopper?
That's a good question. Subdi is available to you in Grasshopper, and I'll show you the icons that are in there now. But you can also exploit the use of meshes. So in the same way that you can extract the control polygon, and I showed you that shaded control net, you can do that for the SubD in Grasshopper as well. So in your params geometry, you've got a SubD empty bucket, as I like to call it, and I'm going to set one SubD. So now that SubD is referenced. Now what can I do with it in Grasshopper? I can take the surface section, surface tab in Grasshopper, go to SubD, and you can see there's a bunch of stuff here. So SubD from mesh, or mesh from SubD, or SubD control polygon are all ways that you could use this. So if I say SubD control polygon, this is that shaded SubD control polygon. And then you could do whatever you do to a mesh, you can do on this, and then you can make it a SubD again. And it's the same thing. So there aren't component versions for every SubD tool, but the fact that you can do anything to the mesh that you could already do in Grasshopper and then convert it back to a SubD really opens the door for a lot of possibilities.
Thank you.
You're welcome.
Hello, can you make a round hole in the spoon?
Yeah, you can, but it's tricky, and I'll show you how.
Yes.
So if I do a selection like this, yeah, we'll just do all these guys and just delete them. That's not a circle. We know that's not a circle. Precise circles is something Nurbs does, but we can get really close. We can get close enough that a human wouldn't care. And I'll show you how. So if we make a circle like this, I'm just going to make a circle in here like this. And I get this edge loop selection. I'm going to get it kind of close to the circle. Let's get it. I'm totally ruining this spoon, aren't I? I get it close like this. And you start to get like this. What you can do is this. You can say, okay, I'm going to sub-object select that edge loop. I'm going to go into the SubD tools. I'm going to toggle. This is the important part. I'm going to toggle that edge loop selection into vertices. Because the edge loop selection was real fast to do. And then toggling it into vertices selection lets me then go into align to curve and select the circle. And they go to the circle. You can also do it with control points. So if I have, you can see the control point cage is down here. So if I take these control points and I do the same thing, align to curve, select the curve, those control points go to the curve. Now, the more points you have, the closer this will be to an actual circle, like that. So if I take this SubD, I subdivide it, I get my edge loop selection, I toggle it to vertices, and then I use align to curve. It's more precise. A little bit complicated, but align to curve is the takeaway. So it's the align command has a new to curve option. There's also a to plane option in align that is very useful for flattening sections of the SubD.
Brian,
Yes.
can you do Boolean operations in between SubD objects and Nurbs objects in Rhino?
You will result in a Nurbs object when you do that. So Booleans are possible, but you'll get a Nurbs object. So let's say here, let's close up this SubD. There we go. How you like that? I think I don't know what I just made here. Okay, so I'm going to edit myself and not make bad jokes. So let's say we have a Nurbs, a solid. Let's say we have this box here. All right. And we select both of them and we do a Boolean union. We now have a poly surface. So in the same way that you can do a Boolean operation with Nurbs and meshes, however, you will always end up with a mesh, it's kind of the same thing. You can do Boolean operations with SubD and Nurbs, but you'll always end up with Nurbs. Note the patch count. Note the patches of the poly surface here. So if you wanted to do a Boolean operation but not have this many surfaces with the SubD, you'd use 2 Nurbs first so that you get that very limited number of surfaces. and then do the Boolean.
May I ask a question?
Yes.
I reverse engineer, so I'm dealing with like 500,000 meshes. Yep. And if I try and convert them to Sub-D, crashes my computer. What is the limit of?
Yeah, so that's a very good question, and it's one of the hurdles that you're going to hit with Sub-D. Think of it the same way as when you rebuild a surface, a Nurbs surface. If you gave it 500,000 control points, it would be really difficult to edit, and it would be very heavy. In the same way, it's that face count of the mesh, the number of polygons in it. That's going to transition to the face count of the Sub-D. And if it's that many, it's not going to be fun to work with. So quad remesh is the best solution I could recommend for that. Take your very dense mesh, use quad remesh on it, because most likely a dense mesh like that is comprised of triangles. They're going to be three-sided faces. Those are not the best thing to feed into a Sub-D. Sub-Ds prefer quads. You can have tris. You can have five-sided faces, which are often called n-gons or more. But what it really loves is quads, four-sided faces. So use quad remesh on that dense mesh that you have and try and get to like 5,000. Remember that mesh that you make is going to be the control net. So unless you're trying to capture really, really fine, minute detail like scroll work, that's millimeters, then you probably don't have to have a lot of faces to describe the shape. So quad remesh, and again, that icon is right here. You could make several meshes and then individually convert them to Sub-D with the toSubD command to see which you prefer, or you can make the Sub-D directly in the quad remesh dialog.
Thank you.
You're welcome. Oh, one more thing I'd mention to you, because I've done a little bit of this on the side myself. There is a fabulous reverse engineering ability with the Sub-D. You can use the pull command to pull Sub-D vertices or control points to other geometry. So if you need to match up to a shape, remember you can use pull to suck those control vertices or control points back to your reference object. It's really nice for reverse engineering.
Brian, that box that you have around the handle of the spoon, that's a Nurbs. Can you make it a Sub-D? Somebody wants to know if you can take Nurbs to Sub-D.
You can, however, it's not going to be what you want if it's a trimmed surface, because Sub-Ds aren't going to allow you to take that quad and trim it into a circle like you can with a Nurbs surface. So if I were to take this and make a Sub-D from it, it's going to try and make a Sub-D from every surface. And these untrimmed surfaces here are going to transition fine. But if we started to put in fillets here, it's not going to transition great. And so this kind of relates back to the previous question. Quad remesh is one road. So we've got this poly surface. I'll say, what's it going to look like if we take this entire poly surface and we say edge count, or we're going to have to use target count of 2000, and then I'll hide input objects. So this is a Sub-D. Now the balancing act begins. We know we don't want to have so many faces in the Sub-D that we can't edit it anymore. So the balancing is, let's reduce the quad count until we're somewhere in the range that we're capturing the shape, but we don't have a lot. So maybe 100. Is 100 too little? maybe 100's too little. We're starting to lose that box shape, but it all depends. And here it's got a little problem here, but we could either use stitch or fill there. There's all sorts of stuff you could do.
Thank you.
You're welcome.
I think we don't see more questions. Those
Okay.
are related. When is Rhino 7 ready?
So we're finalizing the details of that right now. I'd say check back with us next week. Here, I'm gonna put my name.
Look, I have a quick question. It's just if we start working with patterns, let's say we want to do a pattern on the spoon or something like that, do you recommend to start transforming into meshes or go to Nurbs or stay in Sub-D? Let's say we want to do a cross shape pattern like we do in Grasshopper with gradients and etc.
Yep. So that's a great question, and it gets into more details. So these edges, what I would suggest doing is taking the edges and duplicating them. So let's say I dupe edge on all this stuff here. My pattern that you're talking about, my pattern is going to be within this area. Okay. So dupe edge like that. And let's see, do I have one whole curve here? I'm just making, so that's actually, I want that to be separate. I'm setting this up for network SRF. So if you dupe the edges and you make your target surface for your pattern, you make your target surface a Nurbs object. I think that is one of the coolest ways to pattern on top of a Sub-D. You could subdivide the Sub-D, sure. You could make the subdivision of the Sub-D so dense that you could start to sculpt in it. But if you work with people that make design decisions, you're going to ultimately have a change at some point in the process. And that's really why I suggest this workflow. So if we do all these guys here, and then network SRF, right? So if you know how network SRF works, you'll know how to join and explode this stuff. And I'll say, this is my surface. So this is my target surface now for flow along SRF. You see where I'm going with this? So if I have a planar surface like this, and I do whatever pattern on it, array linear, I'll say 4. So something like this. I know it's not lovely, but let's just do a little bit of upfront work here. Dir, that's the direction for V, and we got to swap it and reverse U. There we go. So now if we do flow along SRF and say this to this. See what I mean?
Yes, yes, perfect.
Ultimately, Boolean union together, but this workflow lets you keep the base Sub-D nice and clean and simple. And then, you do your design revisions, Boolean union together. Personally, I think it's really flexible this way.
Thank you, Brian.
You're welcome.
I think we are abusing from your time today.
No, actually, this is my job, but thanks.
I know, but
so feel free to email me if you have any other questions. Happy to help you. I'm part of the tech support and training crew, and you all know Andres and can email him too. But thank you so much for sticking with me today. Hopefully the information was useful.
Hey, Brian, it's Jackie. I just wanted to say thank you. I really enjoy your presentation. I love the way that you present.
Thank you very much, Jackie.
It's just it was very illuminating. So thank you.
We haven't even scratched the surface. I wish we we should do something else on the rendering stuff, because I love to make pretty pictures from the designs, and that would be a whole nother webinar, I think.
Well, you just invited yourself.
I think I just did, didn't I?
Yes.
maybe the first or the second week of December.
Yeah, that sounds good.
Perfect.
Okay. All right.
Awesome. Thank you so much,
Thank you,
Brian.
everybody. Bye-bye.
Thank you, everyone.
Hey, thanks.
Bye.
Thanks, everyone, for attending. Take care.
Thank you.
The webinar will be posted, the recording, next week on our Rhino3D.education page. Thank you, everyone.
Thank you, Lucia.
This conference is no longer being recorded.